Let us now study about parallel combination of resistors. Again here, the idea is to find the equivalent resistance. As discussed in the earlier topic, parallel combination means that the current divides between different branches. Suppose this battery supplies a voltage drop of V, then the same voltage drop appears across all the resistances, but the current divides. Here, the current coming out is taken as I. Now this current finds three branches such that the current through resistance R1 is I1, the current through R2 is taken as I2, and the current through R3 is taken as I3. Now here, if we replace all these resistors by a single resistor such that for the same voltage drop applied, even this also will draw same current I. Such resistor is called as equivalent resistor and its resistance is called as R suffix P. Now here we need to find out this Rp. First, we know that the current, whatever comes out of the battery, divides into three branches in this case because we have three resistors in parallel. And also we know that V is equal to I into R, then I is given by V by R. So this I is equal to, across R1 it will be V by R1 and this will be V by R2 and this will be V by R3. Here the voltage drop remains same, so it is taken as just V. Here we take V outside, then what remains is, it is 1 by R1 plus 1 by R2 plus 1 by R3. Let us call this as 1. Now again here, for equivalent circuit, what we get here is, we get I is equal to, using same form, V by Rp. Let us call this as 2. It's the same voltage drop, the same current which comes out. Therefore, comparing 1 and 2, we can say 1 by R1 plus 1 by R2 plus 1 by R3 is equal to 1 by Rp. Or just rewriting it, 1 by Rp is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So we find that in case of parallel combination, the formula is different. So we can say that the reciprocal of equivalent resistance is equal to sum of reciprocal of each resistances. So effectively, in parallel combination, this Rp will be less than the least of the resistances. For example, if you take R1 as 1 ohm, R2 as 2 ohm and R3 as 3 ohm, this Rp will be less than the least resistance. So this Rp will be less than 1 ohm. So whenever we want to obtain a lesser value, then we use resistance in parallel, and whenever we want a high value, then we use them in series. Now if you have only two resistors, then 1 by Rp is 1 by R1 plus 1 by R2. If you take LCM and solve it, it becomes R1 plus R2 by R1 R2. This is 1 by Rp, or Rp alone is equal to R1 R2 by R1 plus R2. This formula will be very helpful to find the effective resistance of 2 in parallel. Instead of doing this would be very easy. Just by hand this formula, if we extend this argument over n resistors, so if n resistors are in parallel, then what we get from here is we get 1 by Rp would be 1 by R1 plus 1 by R2 plus etc. plus 1 by Rn. If R1, R2 etc. is same as Rn, then what we get is we get 1 by Rp will be 1 by R plus 1 by R etc. plus 1 by R, assuming that each value is same. Therefore, 1 by Rp is equal to n by R, or from here Rp is equal to R by n. So this is the expected equivalent resistance for resistors in parallel.